Welcome to this session in this fantastic bubble of the net zero tent that we are here. Well, already today, we've talked about what is net zero. Is it a useful target? Is it not? We've talked about how we calculate, how we offset, about supply chains. And now we're going to focus on that very clever bit that's in your phones, these phones here, that's in your life, and you might not be aware of. Although actually the fact that you've come to this talk probably means you are a bit aware of them. They're one of the parts of technology that have excited me most in the last few years. Yes, we're here to talk about compound semiconductors, and we have some of the best people in the industry to join us for this. And let's introduce them in the order that they are nearest to us. We have Chris Meadows, Director of CSconnected. We have Tracy Sweet from Cardiff Capital Region. And we have Chris Meadows, Director of CSconnected as well. And they both have, or all three of them, sorry, have a lot of experience in the industry as well. Let's put them at ease with a big round of applause, first of all. And Chris, you get the first question. So anyone here not know what a compound semiconductor is? Should we just spell it out? Just to remind us, because we all know really, don't we? But right, come on, Chris, compound semiconductors, what are they?
Thank you. Well, sorry if I'm teaching grandmother to suck eggs, but a lot of semiconductors are involved with either processing ones and zeros or in storing ones and zeros. So processor chips, memory chips, we have them in our cars, we have them in our phones, and they handle data. They are the digitization processors. But actually, we live in an analog world. If you look around you, you can touch and feel the world, and it's not digital. And so to make sense of this world, we need devices that can either see, and that's photonic devices, or communicate by radio waves, which are not digital, they're analog, and quantum devices, and of course, power, controlling power efficiently. And that's what we do with compound semiconductors. So they feed into the digital world and they take information from the digital world and convert it to something that we can use. And so compound semiconductors provide a whole range of facilities and power management and actually generating power is one of those features.
And Tracy, why don't you try and spell out to us or just list a few things where we might have compound semiconductors in our life without realizing?
Yes, exactly. So essentially, you'll all have a piece of compound semiconductor technology in your smartphone. It does the 3D sensing, facial recognition, so it's in charge of the ID for you to access your phone. It's also in your laptop and in many devices in everyday life.
So we've all got some, probably. We've
Yes,
all got some.
Exactly, yes.
And we should be very proud of them. But Mike, come on, you can do a bit of boasting for us. Because in Wales, we are really good. We're not just pretending. It's not, we are really good at this stuff, aren't we?
Yeah, absolutely. We're really good. And, the type of semiconductor that I look at is for power, for processing energy. So we all hear about, semiconductors for AI. So we hear a lot about AI. They're built on semiconductors. You wouldn't have AI without semiconductors. But as well as processing information, they also process energy. And, in 2030, I think it is, 80% of our energy will go through some form of electrical converter through a semiconductor. So that process has to be very efficient. And the semiconductors, the compound semiconductors, the next paradigm shift compared to silicon for taking the technology to a more efficient net zero world. Really.
So Silicon Valley came off the back of silicon semiconductors, didn't it? Now we're talking about gallium nitride. Good afternoon. Now we're talking about things like gallium nitrate, aren't we? And different things. And the impact, if I understand it rightly from conversations we've had in the past, is it's faster, better, more efficient. And we could be could we be a gallium valley? No, a compound semiconductor valley. Could we be that?
Yeah. Gallium nitride is like the Gareth Bale of semiconductors, right? It's faster, more efficient, but they are more immature than silicon at present. I mean, they're in every smartphone, of course, but we've got a long way to go with that technology to make it, more reproducible, more reliable. But absolutely, because we can switch these devices more quickly, it means that we can shrink the systems, the power conversion systems in our phones. So a battery in a car, everybody knows about the battery and about the motor. Not many people know about the power electronics that's in between those. And to extend the range of the car, the frequency and how fast you can switch those devices goes a long way in extending the range of the vehicle and the efficiency of that vehicle. So, absolutely, it's the next step from silicon. And it's really important, as I say, renewable energy is another area. If we want to connect, wind turbines to the grid, we need power semiconductor devices to do that in an efficient way. If we're lacking on the efficiency side, we need to generate more power to begin with, right? Our population is growing. Our demand for energy is ever increasing. We need to be able to, generate, but also to transmit that energy in a very efficient way so that we can use all of the energy that we're generating, not just waste it on the transportation.
Yeah, so Chris, it sounds like, compound semiconductors aren't just part of the solution because you're in things like wind turbines and a new grid and things, but it's also a way of the rest of the industry, the rest of the world, the rest of the economy being more efficient and therefore using less stuff.
Absolutely. And if you look at the sort of losses that Mike was talking about, then I think we're almost approaching 30% of energy being generated by renewable sources right now globally. So we're getting there. But actually, if you look at the amount that's lost in converting, so when you plug something in, your computer or your phone needs about 5 volts, but your house has 240 volts. So to convert that and AC to DC and back again, you lose a lot of energy. And approximately 10% of global energy is lost in that conversion process. So if we converted to something like gallium nitride or silicon carbide, then we could save half of that lost energy, so immediately add 5 percentage points to the amount of energy that we have generated by renewables. So it makes a huge contribution, but not only is it in the conversion and the efficient use of energy that's generated, however, through nuclear, through coal, fossil fuels or renewables, it's actually very efficient at generating that energy. So if you use solar cells, for example, such as space solar cells or those that are used on high-altitude aircraft, then these can actually generate much more efficiently energy than you can from silicon, about 3 or 4 times the efficiency.
Now, I don't know about you, but there are all sorts of things just then that made me think, what? So Tracy, tell us about aircraft and solar and high altitude and all this world.
Certainly. So essentially, silicon semiconductors have been researched for photovoltaic applications for over 70 years, and they're now at around 26% efficiency. The theoretical limit is 33%, so they're almost at the theoretical limit. When you look at multi-junction solar cell technology, which is compound semiconductor based, you can grow multiple materials with different band gaps, so you can absorb a much wider range of the solar spectrum. And we're currently about 46% efficiency. The Schottky-Queisser theoretical limit is 86%, but because we've only been looking at it for 30 years, there's a lot more work that needs to be done.
Okay, so help me there. So basically that means that a solar panel will be much more efficient because not just it'll convert it better, but it'll take a wider spectrum of light. Is that it?
That's correct.
So
yes,
that
yes.
could help in terms of our our consumption as a world, as a nation. Yes. But you're even, are you not? You in your world, you guys, because you're all in the same world. You're even talking about solar planes and things like that. Who wants to talk about that? Tracy, is that you or Chris?
I can touch on some current projects, actually. Airbus has a project called Zephyr that you can Google, and it's actually being used for communications systems. So it can fly at around 80,000 feet, so it's well above civilian aircraft, but not quite into space. And they have a 30-meter or 38-meter wingspan. And those wings are covered in solar cells, very lightweight solar cells that a company in Wales is actually responsible for designing and putting together. And these are currently on trial. Airbus has been trialing them in Phoenix, Arizona, and also in Western Australia. And they can fly, they store up energy so that they can fly overnight as well. And they can stay floating around at 80,000 feet for about a month at a time, carrying lots of communications equipment. So in rural areas and desert areas and so on, where you may need emergency contacts and so on, it provides the equivalent of satellite communications. So these aircraft will be flying around producing that. And who knows how long it will be, but hopefully that technology will be deployed on aircraft, civilian aircraft at some point, either to enforce or to enhance the current energy capabilities, or perhaps to become completely solar.
So to pick up your point about giving that facility to, for instance, people living in a desert area, while some people might say, oh no, that's horrible, whereas ruining those people's lives, presumably that would mean you could be diagnosed for some rare condition to your heart, let's say, from a consultant the other side of the world, even if you lived in a very remote part of the world.
And we can see examples here, and this is where the link between hardware and software comes in. If you look at AI devices and augmented reality, there are examples here of training, but also remotely operating using AR and VR systems, and being a doctor in the UK being able to remotely operate on someone elsewhere. And it needs that interconnection, reliable, solid and robust interconnection, which this sort of technology can provide.
Okay, well, this conversation isn't just about me. If you want to join in at any time, anyone got any questions at the moment? Anyone want to join this conversation? My piece of paper does. Okay, well, I'll carry on. But please, if you want to pop in at any time, just stick your hand up and I'll spot you. Yeah, come on. Yeah. You got a question? Can this gentleman have a mic? He can have my mic. You can have my mic.
Sorry, Chris Baylor, Specific, Swansea University. I had a question regarding net zero kind of footprint, compound semiconductor manufacturing footprint versus the net zero energy required to make those devices. Is there a sweet spot versus sort of floor plan then, if you like, for say a factory where you need enough roof space, or where you get your energy from, because it's such a vast amount of energy needed to create these things. So has that been modelled, and is it something you're looking at?
Absolutely right. And we've got a project called Sin Zero in Swansea, which looks at generating the energy for our fab. A fab in the semiconductor world is a semiconductor factory, a fabrication facility. Fab. We've got a fab in Swansea. And, we've got a project called Sin Zero, because you're right, making chips is very energy intensive, and you've got to look at the total life cycle analysis of these materials in an application to understand how long it's going to take you to get the payback. It could be years, it could be decades in some instances. But, as I say, we've got a project, Sin Zero, which looks to load shift and generate as much of the energy for our SISM fab, Center of Integrative Semiconductor Materials, using as many renewables as possible. And that's twofold, in fact. One is like a security angle as well, because if you have a power cut to these facilities, it can be devastating for your product as well. So we have a 1 megawatt hour battery storage facility, hundreds of kilowatts of wind and solar on the roof, and looking to see how we can load shift and make the process much more efficient. Also, it uses a lot of water as well, deionized water. So, generating deionized water, generating nitrogen, the gases that are needed to make to process these semiconductors is very, consumable intensive, as we say. So we need to, we are investigating all sorts of ways through the Sin Zero project to minimize our gas usage, minimize our water usage, and also dispose of the nasty gases in a more productive way, shall we say? So
what are the nasty gases, and how can you? Are they useful? Are they like an ingredient for someone else?
No.
So how are you going to get rid of them?
Water, obviously. We
Right.
can recycle water.
Water's fine, yeah.
The fluoride, fluorine gases are generally quite toxic, so you have to manage those. There's also a lot of acids. We use an acid called hydrofluoric acid to clean semiconductor substrates. That's really lethal. If you get it on you, it starts to dissolve your bones.
Okay,
so
we
it's
don't
not,
want that
it's not good.
around. Yeah.
So we have to manage that very carefully and try and use as less of that as possible. But yeah, this is an ongoing area of research. We also have like a national grid style control room in our facility as well. So we can identify where the faults are in the fab. If there is a bit of equipment that's faulty and it's usually consuming more kilowatt hours, more energy, more power, we can identify that from a trace that we've got energy tags on all of the manufacturing equipment in the facility. So, we're looking to, it's a real area of research. It's led by one of our academics called Paul Meredith. I'm not the leader of that project, but it's really taking, manufacturing of semiconductors to the next step, incorporating as many renewables as possible and using the least amount of toxic gases as we can.
And I think that I'm not the only person in the room who is also thinking, right, well, lithium we thought was great, and then there was, there's issues, let's say. How good is it for the planet if we started using much more gallium, for instance? These are things that many of us have never heard of until recently, and they're rare, aren't they? And, are we going to be sitting here in 10 years' time going, ooh, gallium's a problem?
Not really. I'm not sure if you would answer.
Yeah, you have that one.
Gallium's not so much of a problem, and actually if we move to gallium nitride, it's a mixture of gallium and nitrogen, and of course that's all around us. 80% of what we're breathing is nitrogen, and actually a lot of the compound semiconductor materials are actually used in relatively small proportions. So if you looked at the amount of arsenic that's in your phone, we use gallium arsenide, which is arsenic, but actually you'll find it's down in the parts per million. So we're actually, to put it into context, compared to some of the traditional factories that you see churning out lots of pollutants and lots of gas, the numbers that we're talking about are actually minute. We're on the atomic scale, so you'd be difficult to find these. These are trace materials. But some of the metals that we use, lithium is not a compound semiconductor, and we don't use it. So technically, if you go for electric vehicles, yes, the batteries are lithium. Perhaps that will become hydrogen power, hydrogen fuel cell in the future. We're agnostic to that because the components that handle the electricity will be the same compound semiconductors. So whether it's the energy is generated by lithium batteries or the electricity is generated from hydrogen fuel cells, we're agnostic. They'll still be processed through the same efficient means with the compound semiconductors.
Yeah, I mean, I brought in lithium as it was something that was held up as wonderful, and then it's like, oh, is it that wonderful? Yeah. But you don't feel that that's a dangerous area for you.
No, it's more about the gases in the processes that are involved that Mike was talking about.
Now, Tracy, Cardiff Capital Region has already invested, hasn't it, in a compound semiconductor. Is it a fab or a foundry? I thought it was a foundry.
Foundry.
Yeah. I like the idea of a foundry. It sort of feels like Peaky Blinders in a funny way, modern Peaky Blinders. But Tracy, you as an organisation of local authorities has invested heavily, considerably, for yourselves in doing that.
Yes,
You're really
correct.
confident, aren't you, as a region, that compound semiconductors are a way forward, A, for the economy and B, for the planet?
Yeah, absolutely. I think compound semiconductor technology, we do have world-leading capability in South Wales. And essentially, the whole remit is to build on that, to build the supply chains, to create more jobs, to create more wealth for the area, more GVA, and also to look at our carbon emissions. Currently in the UK, everybody consumes about 7 tons CO2 equivalent per year. And actually the sustainable amount is 2.1. So we're all using 3 times the planet resources in order to go about our everyday lives. So every single piece of the system where we can increase efficiency and renewable energy generation, it is a win at every step.
So that's one of your motivating factors, is it? That you can help everything be more efficient and create good jobs as well as that?
Yes.
what needs to happen? I'm not sure which one of you wants to pick up this one, it's slightly thorny. What needs to happen from a public policy point of view to help your sector really fly? And the reason I'm suggesting this isn't just because you work in it, but presumably if your sector flies, you enable health, education, or aviation, motor sector. You help a load of other sectors fly, don't you? So what do policymakers need to do?
I think there are two things. One, we want to grow the cluster, but not necessarily by making more semiconductor firms, but by supporting the supply chains. Now, within the cluster, we have companies like KLA, who build the equipment that the world uses to put together the chips. Now, most of the components that go into their machines are manufactured within something like a 60-mile radius. So the aim is to spend within the region as much as possible, but also to stop all of these things going around the world half a dozen times before they get to us.
Because that had been happening. Our phones go around the world, don't they?
Absolutely. So the more that can be built locally, the better. But also in America, the Semiconductor Industry Association has estimated that for every job in semiconductors, it creates 5.7 jobs in the downward supply chain. Right. So it's that leverage effect. Now, unfortunately, traditionally, at the moment, what we produce in Wales gets exported. So between 95 and 100%. So those 5.7 jobs are probably being created, but they're being created in North America, in Asia. So what we're looking at is with some of the new and emerging technologies like healthcare, monitoring devices, wearable devices, and even some of the components for electric vehicles and so on, if we can bring back or establish some of those supply chains, firstly in Wales, but if not in the UK, or if not in Europe, then it saves these components travelling around the world and the CO2 emissions from that. But it also provides the jobs more locally, so adds to the economy. So it's a win-win all round.
And that would be why the capital region's interested in it, wouldn't it? Anyone want to come in at this point? Any questions or points or examples? What you're doing in your organisations? No, great. Oh, you do, don't you? I can see you're twitching.
Yeah, hi, it's Chris Chugg from Vargo Recruitment. But obviously I deal in recruitment and there's significant skill shortages across the piece. How is the industry, the semiconductor industry, actually coping with those, and where do you see improvements could be made?
Yeah. It's very high on our agenda. And actually, before we even get to the skill shortage issue, there's an awareness raising issue, because if you talk to anyone about jobs in the semiconductor industry, they won't have a clue what we're talking about. And one of the biggest issues is that we have school visits into the cluster, into different manufacturing operations. The kids love it, and they think it's high-tech, clean, it's not traditional engineering. I'm sure they go home and tell their parents, and their parents only really understand teaching, perhaps broadcasting, media, and being a lawyer, being a nurse, or they're the jobs they know. So actually, they probably slap them around the head and say, no, get a proper job. So what we really want to concentrate on is outreach, making sure that we can get out into schools, but also within the community to raise the awareness that these are jobs that are available. They're very well-paid jobs. They're highly technical jobs, and to encourage the take-up, particularly of STEM subjects that will lead into these roles in the future. And we're also working with the education side, so that we've developed a range of modules from apprenticeships through to master's degrees and centres for doctoral training, which Swansea University is a good example of.
Yeah, thanks. I mean, we've got a real problem with the perception of an engineer in this country, right? You know, you say you're an engineer, and somebody will say, you know, can you fix my TV, right? I think we need to get across a message, as Chris kind of alluded to, that engineering is a high-tech, highly skilled, valued sector that we all need for our economy, right? And, we've got a number of initiatives. You've seen Innovate UK here today. They've funded a number of initiatives which we've partnered up with CSconnected on, educating, developing new modules, as Chris said, the next generation of semiconductors. That's industry engaged as well. So the cluster partners in South Wales are all pretty much engaged with that and see the need for it. But, we need to do a lot more. We need to do a lot more. One of those initiatives, very interestingly, was with, we partner with the Dragons rugby team locally. And we went out to the schools. We took some semiconductor wafers, nice brightly coloured wafers. And, the kids got to wear clean room suits. They loved it, They preferred it to the rugby, in fact. And no, it was a really, great initiative. But there's certainly a lot more of that required. Could get into trouble for this. My feeling is, I think the industry partners need to be more engaged with it. It's.
Who do you mean by the industry partners?
Well, all
the
of
companies.
the companies in the semiconductor cluster. I think, if you want to develop skills in this high tech area, you've got to pay for it. Ultimately, you need to invest something into it, right? They don't just come off a production line, right? So it's and I mean, I'm a professor in university. I mean, sponsoring projects, sponsor a master student, right? I'm not talking about thousands and thousands of pounds, just a few £100 or a prize. You could give a prize to a student with the best project. My ambition in Swansea is to try and get every MSc and master student associated with an industrial partner, because that's really what builds the community. And that's what we're talking about here, is building a community around semiconductors with our younger generation of students.
But Mike, even earlier than that, when kids decide what subjects to do, for instance, because it might well be later on they quite like the idea, but they haven't done subjects that would help them in terms of that industry. You need to get them young, don't you? And in a way, if you say to a child, would you like to make jammy Dodgers in Cwmbran, they can imagine it, yeah? They know how they're made. Whereas for many of you, you can't even say the brand name of where your products go, can you? So you can't say, we supply X company, can you? Is that a bit of a problem? Because people can't imagine a semiconductor, let alone a compound one. And they don't really, you can talk generally about visual recognition and your phone turning around and stuff like that. Do you think that's part of the hard sale with kids?
Definitely. I don't think that's necessarily true across the board. So for instance, Tesla, which is a well-known brand, electric car company, they use silicon carbide in the electric drive trains.
You're allowed to say we make things for Tesla, are you? Because you're not allowed to say for some of the others.
Well, they've announced it's public information, right?
Yeah.
They've openly said that they're using silicon carbide compound semiconductor chips in their electric drivetrains. So it's not a trade secret or anything like that. So absolutely, you're right. I mean, we've got to bring some of the big brands that are using this technology. We've got to educate and inform our younger generation that is the case. You're right. It is tricky because how can you, especially my field in power electronics and making power electronics more efficient. It's always the intermediate stage. As I said earlier, everyone knows the battery. Everybody knows about a battery. Everybody knows about the motor. Not many people know about the power electronics, which is essential, which converts the DC from the battery into alternating current to drive the motor, right? Now, it's getting that message across. And the way we try to do that with children is to brand it have a car, right? Have a Jaguar, which is, battery powered, and say, look, this is running, and have a big chip inside there.
Yeah,
right?
would you like to work on this? And then they'll say yes.
Exactly.
Yeah.
Exactly. And that's the challenge. It's definitely a challenge for us.
Do you think that's also, Chris, a challenge for the politicians, is that they tend not to have come from a maths and science background on the whole, and they, they perhaps need, if they understood it more, let's say, they might see the impact that you guys could have across the economy?
I think that's true. And if you compare countries such as Singapore and Taiwan, a lot of the government officials have dedicated teams that focus on what their next step is. And I remember talking to someone many years ago about Singapore and would we invest in gallium nitride because they saw the future as being important, and that was their economic development board. And they were very keen to acquire the technology that we have in the UK. And yet conversations with the UK government don't yield that sort of level of detail. And in fact, they change and have short-term plans. So who we talk to today is not who we'll talk to tomorrow.
So when I asked you what do policymakers need to do, it sounds to me that they need a vision and they need long-term thinking.
Long-term thinking, a plan, and to stick to it.
And that's something you can do in the capital region, can't you? Because you're not voted in every whatever. I mean, the members are, but as a structure, you're still there. Does that mean you can have bigger vision and plan further than like a traditional local authority?
Yeah, essentially, what we're trying to do is develop a strategy that's going to go over multiple decades. One thing that we have got in place very recently, we've got some cluster development growth program funding. So we've got 1.3 million to invest. So any industries out there, if you want to come over to our stakeholder event, get hold of me and let me know, because we want to get industry's view, how we can support them best to make progress.
And if people are thinking, well, I don't know what you mean, how could you support them? Is it grants or is it training or is it what kind of support? Because that word is used across a number of beasts.
It is, and it's a whole multiple number of support packages. The CDGB is skills, so we're looking at
What's the CGDB again?
It's the Cluster Development Growth Programme. So that was announced last week. So it's new and shiny, and we're all very excited. But it's a question of getting industries in now in the area to contribute to the stakeholders meeting and to devise future plans. So.
And Mike, how much do you guys all need to be like running on the spot to keep in front? Because, the Compound Semiconductor Cluster in Wales has been at the forefront of things for quite a few years.
Absolutely.
But you don't want to lose that position.
No.
So how do you do that how do universities do it? How do governments do it? How does the industry itself do it?
Well, I guess, staying in front in terms of the technology is around, keeping up to date with the R&D programs, right? So it's great news for us now that we're back in Horizon, for instance.
That's made a real difference, has it?
Well, not quite yet, but we're already
will?
speaking to our European partners about, the next generation of compound semiconductor devices that they're all interested in, and we will get to be an active part of those developments that and share the IP, etc., that's generated from new technologies over in Europe as well. So it's very important for us, of course. From my perspective, looking at new materials as well. So for instance, I'm working on a material called gallium oxide. Okay, we've heard today about silicon carbide and gallium nitride. Nobody's heard about gallium oxide quite yet. It's the next generation of material.
Okay, what will it do that the others don't?
It'll make everything much more efficient.
So it's all about more efficiency, smaller, lighter, faster, lighter, faster.
Yeah, it's about achieving 100% efficiency, net zero, right? That's what it's all about. Because, power electronics actually is already about 90% efficient. I mean, Chris said earlier, 10%, typically 10% you lose, right? But when you're talking about gigawatts of power and you're concatenating these systems, so, if you've got one power electronic converter that's 90%, you don't just have one, you have multiple in a string. So when you have multiple of those in the string and you just multiply 0.9 by 0.9 by 0.9, it ends up being like 60% efficient. Yeah. So we need, we really do need 100% efficiency, and 60% of a gigawatt of power is a lot of energy that's wasted, right, in a system. So we really need to strive to the 100% efficiency benchmark, because if we don't do that, we're forever going to be wasting a lot of energy. And the way to do that is the new materials, the new compound semiconductors of the future. That's the way to do it.
So all the time you're going to be developing more compound semiconductors with different things. Yeah. It's quite interesting because in this room earlier today, we were talking about us having less stuff, doing less, wasting less. It feels like you guys are just trying to always stand ahead of the curve, if you like. Is there a contradiction between that we need to not use so much stuff and just pull our horns in a bit, and what you're doing? Because, like, for instance, in a simple analogy, with your solar plane, we could all pop off on weekends away and hen nights again with a clean conscience, couldn't we? Whereas in the conversation we were having earlier, it was about flying less, for instance. So is there a contradiction in the net zero world?
No, not really. I think it all comes back to the life cycle analysis. Yeah, you've got to understand how much power you can save, how much you're putting into these technologies to manufacture them, and what the payback period for that is, right? If you do that analysis up front, then you're good to go, right? I mean, if it's going to take so much power and energy to develop a technology, then you have to ask yourself, is it worth it? And it's not just energy and power. It's also investment. So, for instance, one of the difficulties I feel gallium oxide will face in the future is getting the investment from industry. So silicon carbide and gallium nitride, for instance, they've had a lot of money invested from automotive companies. It's a huge market, massive market, essential technology. When we look at a technology like gallium oxide, we're talking about grid level, transmission and distribution type networks. Now, the private sector in that area don't want change so much, and there's not the volumes aren't as large, right, for that kind of device. So, it's investment and it's payback time to achieve net zero, right? So all of those have to be factored into any sort of calculation.
And Tracy, where those companies are headquartered, the companies in that sector that are growing in the future, where their headquarters matters, doesn't it? So,
it does,
presumably as a capital region, you're wanting Welsh companies that keep the profits here as much as possible, unlike the early stage, for instance, of wind energy, where the profits, like the wind, flew to other countries.
Exactly, yes.
Is there room on that? Can we realistically, I mean, we've got IQE, we used to work at IQE.
Yes.
Can we realistically think that we can develop a really high-tech, global leader, Welsh-owned businesses here? Or is that like one step too far?
I think there's a lot of work to be done to join up the separate pieces, but I think that we have got the expertise in this region. And I think essentially we need to invest in it. We need to develop it further. It's come a long way in the last 30 years. And also aligning government strategy. I think, looking at the long-term game is what's important here.
Yeah, we're not getting much of that really at the moment, are we?
It's short-term election focus.
Yeah, so we need that. But you can do that, can't you? As Cardiff Capital Region, you can take the long view.
Yeah, exactly. And I think that's what's really helpful.
And how do you persuade people that that's what you're doing? Because culturally, we're not used to the long view. Are people beginning to get it, that the city region can behave differently to a government or councils?
I believe so. I've only been in the job 4 weeks, so the limited number of people I've spoken to have been very enthusiastic about what we can do, what we can enable, how we can help them. That's essentially our role. And so we're certainly just up for collaboration and building the supply chains that we have.
And it's not just about industry, is it, Chris? I mean, I've spoken to you about these things before. It can actually compound semiconductors and the things that they enable can actually change people's lives in other aspects rather than just jobs, can't it? In terms of their quality of life.
Yeah, I mean, medical technology, healthcare, wearable devices are all really key areas. And again, the efficiency on how they operate is important. But for things like glucose monitoring, potentially for cancer markers and so on, these are all technologies that we could be wearing on our wrists. And then this is where the connectivity through these flying devices comes in, because we could all be monitored 24/7. The data could be aggregated, but only when something goes wrong does that raise alarm bells. And that then, using AI, could alert your GP in this country or whatever it is elsewhere, and action could be taken to avoid having an illness, if you like, rather than treating it after the event.
Some people might feel they're being spied on a bit. Am I the only person who thinks others might feel spied on? Like, so if I drank too much at the weekend, my GP would be informed. Is that what would happen?
I think
Not that I would, of course.
I think that's a whole different debate, and of course, insurance companies would love to get hold of the
Well, of course
technology
they
as
would.
well.
But more seriously, you mentioned earlier on, right at the beginning, about these amazing devices flying around the planet, able to get solar energy and transmit down to us. Tell us a bit more about how that would actually impact our lives, or how it could.
Well, I mean, to take it to an extreme case, there are a lot of research projects, including Cardiff University on this, looking at generating solar power in space and then beaming it down to Earth, because it would be much more efficient to do that. Of course, you don't really want to be standing under that beam, but there are ways of conducting that. So we may see that sort of technology starting to develop. And of course,
Can I pause you on that? So would that make us less responsible? Save less energy if we just thought, or not change our behaviour because we think, oh, we'll just get it from up there.
I think it comes down to a combination. As you asked earlier, we're talking on one hand about cutting down what we use, and on the other hand about making it more efficient. I think we need the two, because as Tracy mentioned, we're using 3 times more energy. Our carbon footprint is 3 times what it needs to be sustainable. So if we can say 50% of it cut out of that extra, but the other part of it we make much more efficient in the way that we use that energy, then it all contributes towards reaching that net zero. So I think it's not a single answer, but a combination of much more efficient devices as well as cutting down what we do.
And that would then knock on to the way that we're treated, the energy we get, the way we're treated by doctors, the where we're treated, our lifestyle, our safety.
Absolutely, yeah.
Question over here.
So I didn't know anything about semiconductors before I came in here, but I now know a lot. It's sounding a bit space racy. What's collaboration like internationally? It sounds like we can't put the genie back in the bottle, and semiconductors are here, and gallions and nitrates and oxides. So every country in the world is on this. How open source is it? What's the level of collaboration like? I imagine there are panels all around the world sitting here having these conversations. How much are you all talking?
Well, first of all, within the cluster, one of our key strengths is collaboration. But actually, the semiconductor industry was the world's first global industry, perhaps for the wrong reasons, but Silicon Valley started to look for cheaper ways of manufacturing semiconductors, so they went to Asia, and they started working with countries like Japan, and they lost a lot of IP. They thought they could protect it through something called Moore's Law, in that everything was getting more complex. Therefore, if we outsourced to Japan how to manufacture memory chips, they'll never catch up, because we're always going to stay one step ahead. Well, of course, that didn't work out. And then the American government worked with the Korean government to try to encourage Korea to grow in this area. And the Korean government encouraged it was a fruit and veg company, you may want to Google, called Samsung. You may have heard of them, but it encouraged them because the troubles that they have in Korea, there are 4 big family-owned firms, Samsung was one of them, then operated, funded by America, to produce memory chips to stop Japan flooding the market. So this collaboration, good or bad, has been happening within our industry way before it happened in any other industry. As it happens, it is very collaborative now, as Mike mentioned, through Horizon. We work very closely with Europe. And actually, there's a lot of work. If you look at companies like IQE, it has manufacturing plants in Taiwan, in North America, had them in Singapore. So we've actually embraced a lot of international cooperation. There is a move at the moment to deglobalize after decades of globalization. I think it's going to be difficult to get away from that. And interestingly, there was a Pentagon report that said, beware of working with foreign-owned companies. And that was 1989, and it was referring to Japan. So we keep going round in circles on this. I think ultimately it will be a global industry. If you look at the way that a handset is launched, it used to be launched in one country, then another country, then another country. If you look at Apple now, they will launch the next model of iPhone, millions upon millions of them around the world simultaneously. And it's very difficult, as you say, the genie's out of the bottle. It's very difficult to step back from that. So there will be disruptions in that, in supply chains, but ultimately I think we'll end up being part of a global industry. So we need to make sure that we've made our mark and we maintain our position.
And we want a dragon flag on all of these things.
Oh, yes,
There
yes.
won't be room,
So-
they're so small.
so-
Was there another question? Sorry, Jenny.
Sorry, it's not just the manufacture, but it's also all the new thinking. So all the solar you're trying to put on the top of the factory and what you're trying in the fab and all those things you're doing. It's also the new thinking rather than the actual manufacturing or the supply chains. Is the collaboration around that? Are you getting together with people in other countries and sitting around a table going, what's the fresh thinking on this? So it's not just the manufacture and the collaboration I'm really thinking of. It's the reduction of the carbon footprint, or it's the solar piece, or whatever it happens to be.
Yeah, absolutely, it is. I mean, the question originally was, how open source is it? And what I would say to that is, making, manufacturing, designing semiconductors, is a capital intensive exercise. You need a lot of money for a fab, right? I'm not sure if you're from a software background, but that's the there's no open source in the software sense in manufacturing chips. So, we very much need, to continue, as Chris alluded to, with a global approach. And, going back to what Chris said, you asked as well if it's a space race. It sounds space racy. The original silicon chip was built off the back of the space race where the Americans were trying to beat the Russians to the moon. That's why the first transistor switch in silicon was developed, So a company called Fairchild was given a lot of money by the US government to develop that to beat the Russians to the moon. And of course, after that, they commercialized it through the transistor radio, and the rest is history, right? Now there's usage everywhere for the transistor chip. But, in terms of, the thinking around semiconductors, there are clusters around the globe with, capital intensive clusters, which you need to manufacture semiconductors, which through programs like Horizon, there's a joint program with Taiwan. I can't remember the name of now, a UK Taiwan Innovate UK type program. ITRI, thanks, Chris. That's the reason that these types of programs exist, is because they have equipment and capabilities that we don't. We have capabilities that they don't, which are very expensive to develop, right, and to bring here. So, learning from each other is a collaborative approach, a global approach is essential for this technology. It's essential.
Mike, thank you. Tracy, you wanted to very quickly.
I was just going to say, in the example that we just talked about, ITRI, that was something that IQE collaborated with. So essentially, in order to develop the fabrication process, those organisations need the base epitaxial wafers to work on, and that's where a supply like IQE comes in.
Well, thank you all very much. Thank you as well. It's been great to hear a bit about the future as well as now, and Wales actually doing really well at something. Don't mention the rugby. Thank you very much, Mike, Tracy, and Chris.
Thank you.